as a brief introduction to the Tech Talk, this is something that is being put on by the Technology Network to kind of give you some insight of some of the technological things that are out there, create some ideas, and give you some things to think about, especially in food safety. So I'm Tim Barthel. I'm with Cybertrol Engineering. We are a systems integrator, and I'm also the chairperson of the Technology Network for FPSA. So what I'm going to be talking about is something that is really important in food safety, and that is the FDA requirements for validated, information, and how can you get that into an electronic fashion. So this is going to be one of the ways that is being done, and I'm going to be showing it in the form of CAP systems mostly, but we'll be talking about some other options as well, other reporting type items. So to start, just kind of a background, you guys in the food industry, seeing food safety, the traditional data recording is very paper heavy. You're familiar with the circular chart recorders that gather temperatures, flow rates, other critical information that's needed to make sure that everything going out is done safely, whether it's temperature of ingredients or how it's been cleaned or pasteurization, all of those different items. There's also a lot of just manual data recording. A lot of these aren't technically validated, but there's a lot of room for error. Anytime someone is handwriting something down that the control system is gathering without capturing it automatically, you have just room for error. So for those of you that may not be quite as familiar, the traditional chart recorder that is used extensively throughout the food and beverage industry is, and this is for CIP reports, it's typically 3 pens. They measure the temperature, your conductivity, which is your chemical concentration, and your flow rates. While they're doing their operations, they have to open it up, initial things, date it, make little annotations on the chart recorder, and then initial as they go. And these are stored then in just a filing cabinet. So some of the things that we've moved our customers towards, and I've seen it kind of starting to gather momentum from people that even aren't our customers, is doing this electronically. It was a big uphill battle for a while trying to get it electronic, simply because the people validating these, the inspectors, like things the way that they know will follow 21 CFR Part 11 or PMO or other FDA requirements. They know what they know and they like to stick with it. But if you look at these side by side, you can see one is a very readable format. You can see kind of what is the levels that your chemical, your temperature, and your flow are, in a linear fashion, instead of analyzing it in a circle. And you also get more information that can come through the control system with what are the steps that it's in, what are comments that are typed in by the operator, what are the alarms that are happening. So it allows for, a little additional troubleshooting ability if you do see some sort of anomaly. So in a nutshell, you have basically the same type of connections happening. You got your control system, which is your PLC on the floor, your field devices wired to it or directly wired to the chart recorder. And that is a circular chart recorded, and that's put into a file cabinet. So you have to search for it by date. Hopefully it wasn't dropped in a puddle of water. Where on the right side here, you have the electronic reporting, still the same control system. You put it into a secure database. You then are allowed to use that data in multiple formats for reports that many different users can see with the right credentials. So it opens up all of that viewing ability, and it makes all the approvals, all the quality approvals, the FDA approvals much quicker and much more seamless. I can say from experience that even the inspectors that were a little hesitant, once they got used to it, they never want to go back to circular chart recorders because it speeds up their job tremendously. Some other things that we've done is like fermentation, tank reports, a lot with cleaning reports. I will say one of the challenges that's out there is pasteurization. An HTSD does not allow for direct electronic reports. There are now some digital chart recorders that are coming out that have their own proprietary software that are starting to be recognized by the PMO. But using standard SCADA and control software and getting a 21 CFR Part 11 compliant report, HTSDs don't fit into that quite yet. So what's the difference? How are we meeting the requirements for 21 CFR Part 11? Signatures is a big thing. You have time-stamped electronic signatures compared to the handwritten, and that is validated. That's one thing we had to get validated. Comments, we're keeping the comments in place. They are time-stamped and they are typed in, and they're needed with validated electronic signatures. So on a traditional CIP, there's a handwritten one and then they have to initial it. Tampering. The data acquisition needs to make sure it's tamper-proof. You can tamper a paper chart recorder if you make an annotation later. There's no way to make sure it's date stamped, but it is still legal today. The good thing with the electronic is there is timestamps on everything. And the data acquisition model, using a historian or a SQL database that is secured, does not allow for data tampering if it's done to these standards. Validation, you can see the side-by-side comparisons from the HMI, the gauge, and seeing the historical value right on your SCADA system. Typically, validation of a hardwired, circular CIP chart recorder, you do need like a gauge reading to compare it. So redundancy is something that is available in electronic CIP reports, but it's not available in the traditional circular chart records. It's a paper record, but you have to photocopy it to make sure you have redundant records. With electronic, you get all the data. You can do a backup of it. You can actually export it into another external database. And there's multiple ways to get this redundancy. We have also auto-generated PDF reports that will be emailed to various people, so they get that redundancy built in that way too. Security, lock and key for a file cabinet if it's needed. It is done through Windows authentication through your domain in the electronic method. So that's something that the IT group does manage, and it's a solid way to do it. And then another thing with backups, offsite record retention can be automatically scheduled to have that happen. If you do offsite record retention, you do need to load it up into a box, load it in a truck and bring it to some sort of offsite location. So kind of wrapping a lot of it up, the way this happens is through the SCADA system, the security within it. You have screens that are built that will show you the data in real time to make sure that it's being logged, so you can visually see that it's happening. You get some drop-down lists so they can select things that they need to have. You can put limits or even items in there so that quality gets triggered and a process can't continue if it's outside of a safety range, something that a circular chart can't do. The operator authentication is done with a pop-up window, and then that's tied to Windows security. Version control needs to be done. So programs like Rockwell Asset Center are used to make sure that nobody can edit the PLC program under the hood and change how the data is being logged, and make sure that if it is logged, if there is a change that happens, it does follow the procedure to make sure it stays validated. And then you make sure that all of the software that is being accessed is limited to use of thin clients. Someone can't go in and manipulate some of the screens or whatever without the proper validation.